We're now going to look at a mixture of past HSC questions. So 2015, question 13. So that makes it, what's that, around about the middle of the ones where you have to provide the solutions to. So they're giving us two hyperbolas, one where it equals one, where it equals -1. So in other words, the first one, the foci is on the x-axis. The second one, even though it looks like it's minus y squared, it's equal to -1. So really, it's minus x squared and positive y squared, so the foci is on the y-axis. So P is the point, okay, so a standard parametric, and Q, because the x and y flipped around, becomes A tan theta, B sec theta. All right. Verify the coordinates of Q satisfy the equation for H2. It's a bit of a gift question, really. Yeah, exactly. All you've got to do is sub into the equation and show that it works. So x squared on a squared minus y squared on b squared. A squareds cancel, b squareds cancel. We get tan squared minus x squared, which, yes, is -1. So, okay, we've got the coordinates of Q. Show that the line PQ. Oh, this is just standard coordinate geometry. You know, find the slope, point slope formula. Hopefully, we'll get that. So slope PQ, B tan minus B sec, A sec minus A tan. That's just minus B on A. Point slope formula. Playing around with the algebra, we get what they want. Well, so not a bad question so far. There's a couple of nice marks we should be picking up. Prove that the area of triangle OPQ is independent of theta. So when we get our final answer, there should be no theta in it. Okay. If you look at the diagram, we want triangle OPQ. We just found the equation of PQ, which would be the base of that triangle. So if I find the perpendicular distance from O to PQ, that'll be the perpendicular height of the triangle, then find distance PQ, I'll go half base height. So all right, perpendicular distance formula. And because it's going from 0, 0, so there's no x, no y, it's just minus, there's the constant, over square root of a squared plus b squared. Not much more I can do with that. Distance formula for PQ. Let's tidy that one up. Half base height, so the square root of a squared b squared cancels. Tan squared, of course, tan squared minus sec squared is 1. So that one disappears. I just get half AB. There's no theta in the answer, so yes, the area is independent of theta. The one from the year before, 2014, again, about halfway through the paper. This time, it's a hyperbola again. They've told us the focus, our points. That's a bit strange. Oh, of course. These points aren't actually on the hyperbola. So I was thinking that was a strange parametric to use, but they're actually just points on the asymptotes. So P is AT BT, Q is A divided by T, B divided by T, M, and they've given us the coordinates, just in case we couldn't add together and divide by 2. It's the midpoint. Okay. Show that M, again, nice gift mark to start off with. Substitute in M. There's M. Put it into x squared on a squared minus y squared on b squared. Fingers crossed this should equal 1. Oh, yeah, bit of expanding to do. But yes, eventually we come down to 1. So, yep, okay. Prove the line through P and Q is a tangent to the hyperbola at M. Slope PQ, B outside of t squared plus 1 on A t squared minus 1. But essentially, yeah, the slopes have got to be the same. So if we find the derivative, I get b squared x on a squared y at M, because we've got the coordinates of M. Oh, here we go. At the point M, the slope, it's equal to the slope of PQ. Does that prove it is the line PQ though? Might be parallel, mightn't it? Yeah. Okay, so all I've done at this stage is I've shown that PQ is parallel to the tangent. However, but M lies on the line PQ. So therefore it can't be parallel, it must be the line. Ooh, more to the question. Show that OP times OQ is OS squared. Okay. OP times OQ ends up being A squared E squared. That's nice, because S of course is the focus. So E squared is A squared plus B. That's explaining how I got A squared E squared, isn't it? So I've gone from A squared plus B and jumped there, which I suppose, because it's a show that or prove, yeah, I should really explain how I could just jump from there to there. And that is OS squared, because OS, of course, is the point AE naught. If P and S, they've got the same x coordinate, so vertically they line up, show that MS is parallel to one of the asymptotes. Okay. So P and S now have the same x coordinate. Well, we know the x coordinate of S is AE. So AT, that was the x coordinate of P, equals AE, so T must equal E in this situation. The slope of MS, because I'm trying to show it's parallel to an asymptote, B squared E squared minus 1 over 2E over A E squared plus 1 over 2E minus AE. Ooh, it looks horrible, but actually tidies up quite nicely. We just get minus B on A. And that is the slope of one of the asymptotes. 2000, so same paper, but in the next question, this time they gave us an ellipse. Standard one, A cos theta, B sin theta. Acute angle between that, they've told us, is phi. Show that the tan of phi, that expression. Well, what can we do here? The only thing I can really think of here is angle between two lines. Use that formula. That would come up with tan alpha. So I'd need the slope of OP, and I'll need the slope of the normal. I'll need the... So let's differentiate. There's dy dx. So slope of the normal, A sin theta on B cos theta. Slope of OP, B sin theta on A cos theta. So tan phi will be slope 1 minus slope 2 over 1 plus slope 1 times slope 2. Now, on the bottom of the fraction, what have I done? I've multiplied top and bottom by cos squared, haven't I? Yes. So the bottom became cos squared plus sine squared. But cos squared plus sine squared is 1. And see, this is where I've come up with something slightly different to what they asked to show. So remember, they said times sine theta cos theta. Well, I've got it as the absolute value of sine theta cos theta. That's where I think I need to point out, well, if P is as illustrated, then I know theta is acute. But remember, P was just any random point. So had it been somewhere else on the ellipse, theta might not have been acute, and then it wouldn't have worked because I would have got negative sine theta cos theta. So that's why I've got absolute value. But now, the reason I can get rid of the absolute value sign is because I know sin theta and cos theta, if it is as illustrated, would both be positive. So there's tan phi. Find the value for theta when phi is a maximum. Okay. Sin theta cos theta, half of sin 2 theta. Nothing too special there. But what I do know is sin theta cos theta, therefore, is a maximum when sin 2 theta is a maximum. And the maximum for a sine curve will occur, well, the first time it'll occur will be at pi on 2. So 2 theta is pi on 2, so theta is pi on 4. So I now know that sin theta cos theta is a maximum when theta is pi on 4. Now, a squared minus b squared on AB is a constant. So therefore, tan phi, which remember was a squared minus b squared over AB times sin theta cos theta, must be a maximum when sin theta cos theta is a maximum. Because the other part's a constant. So again, that must happen when theta is pi on 4. As tan phi is an increasing function, phi is also a maximum. Now, why did I need to mention that? Let's just go back and have a look at what actually the question says. Find a value of theta for which phi is a maximum. So let's go back. Tan phi. So we've just proven tan phi is a maximum. We haven't proven phi is a maximum. That's why I needed to mention that last bit. So tan phi is a maximum when theta is pi on 4. But now I say, well, I know tan phi is increasing between 0 and pi on 2. So if that's the maximum for phi, for tan phi, if that's the biggest tan phi can get, then because it's increasing, then the angle can't get any bigger either. Because if the angle got bigger, tan phi would be bigger. All right, 2013, a rectangular hyperbola. So tangent to the hyperbola at P intersects the x-axis at A, okay, yeah, and the y-axis at B. And a similar thing happens over there on the other branch with C and D. Okay. All right, starts off with a nice gift mark, show the equation of the tangent. So differentiate, sub in, point slope, there we go. Show that A, B and O are all in a circle with a centre P. Okay, I mean, my diagram's not there, but if you have a look at the diagram, we certainly know triangle AOB is right angled. Because A was on the x-axis, B was on the y-axis, and O is the origin. So if it's right angled, there must be a circle that goes through those 3 points, and AB is the hypotenuse, so AB would be the diameter of that circle. Now we've got to prove P's on AB, or is the centre, if you like, because it's saying it's the centre P. But we know AB is the diameter.
You need no midpoint.
So, all right, we got that AO and B are all on the same circle. AB is the diameter. The centre of the circle would be the midpoint of AB. Okay, so the coordinates for A, y is 0, x is 2cp. Coordinates of B, x is 0, y is 2c on P. So the midpoint, sure enough, is our point P. They turn out to be CP, C on P. So yes, P is the centre. Prove that BC is parallel to PQ. BC is parallel to PQ. Okay. I've actually drawn a third line in there as well, you'll notice. I've drawn in AD. Now why have I done that? We know P is the centre of a circle that passes through A, B and O. Okay, that's what we did in part 2. Similarly, Q must end up being the centre of a circle passing through D, C and O. Because all we've done in part 2 is proved that if we got a tangent and we get the x-intercept, the y-intercept and the origin, those 3 points will lie on a circle. Well, if you go and have a look on the other branch, what have we got? We got a tangent, we got the x-intercept, we got the y-intercept, and we got the origin. So again, we could have said a circle will go around those 3 points. And Q would be the midpoint in this case. So I know that AP equals BP, because they're radii of that circle. But it also means DQ is equal to CQ, because they end up being the radii of the second circle. So they're equal radii. So the ratio of AP to BP is equal to the ratio DQ to CQ. Ratio of intercepts. That's why I drew that third line in. So therefore BC is parallel to PQ is parallel to AD. I didn't actually need to prove the parallel to AD, but I've done what they want. They wanted me to prove that PQ was parallel to BC, was it? I think.